Welcome to Mathenatic. In this video, we'll determine the derivative of fx from first principles, where fx is equals to 1 over x. So when they ask you to find the derivative from first principles, you would need to use the equation of the limit of h towards 0 for fx plus h minus fx over h. So for fx plus h, we would substitute the x in our equation with x plus h. And if I do that substitution, I'll have the limit of h towards 0 for 1 over x plus h minus 1 over x over h. So this might look a little bit intimidating, but let's see what we have. Our first term in the numerator is simply f with x plus h. So I replaced x with x plus h. Then our second term is simply fx, which is 1 over x. Now, when we have a compounded fraction or fractions within fractions, what I would like to do is I would like to remove this denominator or write it differently. So that will look like the limit of h towards 0. Then I'll keep the numerator in brackets, which is 1 over x plus h minus 1 over x, close the bracket, and I'm dividing that by h. So actually what I'm doing, instead of saying divide by h, I'm writing down divided by h. So this will allow me to simply write the numerator as one fraction. Right now it is 2, and I can also use tip and times to change the divide into multiplication. So we can make that multiply by 1 over h, where I take the reciprocal of h. So let us first rewrite the numerator as one fraction. So this is the limit of h towards 0, and now I identify my lowest common denominator as x plus h times x. So that is x plus h times x. That's the LCD. Then in our first term, we already have x plus h in the denominator, so we need to add an x. So what I do in the denominator, I would repeat in the numerator. And in our second term, we already have an x, but we need to add x plus h. So I'll also add an x plus h at the top. So we'll have 1 times x plus h. And that becomes negative x plus h. Close the brackets. And I'm going to tip and times. So I'm going to change this division into multiplication and have it as 1 over h. Before we continue, what I'd like you to notice is that I'm keeping the limit in front of my fraction because I cannot yet substitute h with 0 in this equation because it will become invalid or undefined. So now that we have rewritten the numerator or the first fraction as a simple single fraction, we can add like terms together in the numerator. So we'll have, this is the limit of h towards 0. Keep the brackets. This is x minus h over x plus h times x. And if I want to, I can actually multiply that h into the denominator. So what I'm doing is I have removed the set of brackets, and notice it becomes negative h because we multiply negative 1 with x and negative 1 with h, and that's where the negative h comes from. And then in the numerator, I'm actually just multiplying that by h. That's where that h on the right-hand side comes from. In the numerator, I'm simply multiplying whatever I have by 1. So whatever you have multiplied by 1, and that will remain as it is. Now for our next step, we have the limit of h towards 0. Remember, we can't substitute in with 0 yet because the whole thing then would be divided by 0, which is undefined. And in the numerator, we have x minus x, which is 0. And we simply have negative h over x plus h times x times h. So now we have one term in the numerator and one term in the denominator. And when you have one term over one term, then you can look to cancel out. And I can see that I can cancel out the like terms of h. If I simplify, this becomes the limit of h towards 0 for negative 1. Remember, the h is cancelled out, over x plus h times x. Now, I can remove this limit by substituting h with 0. So if I substitute 0 in the place of h here, we still have x times x. So the denominator doesn't become 0, so it's a valid substitution. So this will be negative 1 over x plus 0, which is simply x, times x. So you can also write it as negative 1 over x times x. And if I simplify that further, this is negative 1 over x squared. So the derivative of 1 over x is simply negative 1 over x squared. Notice that I kept the limit in front up until I substituted h of 0. And also notice that I used the tip and times to get rid of the compound fraction. And my numerator, I simplified by writing it as one fraction. And that's how we find that first derivative.